Okay, YouTube, this is just the video in which we're going to work through an example of solving a 4x4 system, or a system that has 4 variables just using Gaussian elimination, but the same process, and talk about how that could be extended to any number of equations with any number of variables to process. So let's go ahead and start with this. If we were to solve a system with 4 variables here, we'd have to set up our augmented matrix associated with it. So we'd say that this would be a 2, we'd have a 2, a 1, a 3, a -1, and then we would have a 6 for a constant here. So getting this filled out, we have a 1, a -1, a 2, a -2, and a -1. Here we'd have a 1, a -1, a -1, a 1, and a -4. And then last but not least, we'd have a -1. Got a little carried away there. 2, -2, -1, and then a -7. So here's our augmented matrix associated with this. We're always going to start by trying to get a 1 in the top left corner. So I think that we could easily do this if I were to switch, say, my first row with my, say, second row here. This would get this 1 in the top left corner. So to rewrite this here, I'll try to write a little bit smaller. We're going to write on the outside here what we've just done. We're going to switch row 1 with row 2. And to do this would make our row 1 now 1, -1, 2, -2, and then our constant here would be a -1. And then our second row would become what our first row was, which was 2, 1, 3, -1, and a 6. Now our second two sets of rows here did not change. So we still have those values there, those entries, and we say -1, 2, -2, -1, and -7. So here's our new matrix. Now that we've got a 1 in the top left corner, what we're going to be doing is basically using that 1 as an instrument to make everything underneath it into a 0. So this process that we've seen occurring is basically the usage of this 1 and multiplying by the opposite of the coefficient that we're going to add it on to get it to cancel. So that is to say that row 1, if we take it times -2 and add it to row 2, this would cancel. So we're going to say -1 times row 1. We're going to add that to row 2. That will get this to be a 0 here. If we took -2. What did I write in a -1, you guys? -2 times row 1 plus row 2 would get this to cancel. If we take -1 times row 1 and add it to row 3, we would get our +1 to cancel. And if we take a +1 times row 1 and add that to row 4, we would get this -1 to cancel. So essentially row 1 is still the same, 1, -1, 2, -2, and our constant -1. But underneath it we would be guaranteed to have zeros here. So now the rest of this we have to work out, but it'll become quicker and quicker as we narrow this matrix down. So if we took -2 times all of our coefficients in the first row here, we could work these out. We'd say -2 times, and this is a -2, -2 times a -1 plus, and in this entry here we had a 1. So we would say that there's that entry there. If we were to take a -2 times a +2, so we say -2 times a +2 plus, and we were adding that to a 3, so plus a 3. We would get that there, and then we do a -2 times a -2, so we have -2 times a -2, and we're going to add that on to this here, this -1, plus -1. We would get this here, so we have a 3, -1, and a 3, so we have 3, -1, 3, and then we have to do this last one, -2 times, let's do this mentally, -2 times a -1, which is a 2. 2 plus the 6 here would be an 8. So you can see how you could use a calculator to do this. I'm going to go ahead and do the rest of these calculations mentally here out loud with you, but we say if we took -1 times all of these entries in row 1 here, well, we would have got -1 times a +1 is a -1, and adding that to this one here made this a 0, but -1 times this -1 here is a 1. And adding that +1 plus this -1 that was originally there, we get a 0. -1 times this +2 here would be a -2. And -2 plus this -1 would be a -3. -1 times this -2 in the first row here would have been +2, and +2 plus this 1 that was here is a 3. And then -1 times this -1 is a 1. And 1 plus a -4 would be a -3 here. So now moving down to our last row, we took everything in row 1 times 1 and added it to row 4. So basically, let's add all the entries from row 1 to row 4. So 1 plus -1 is 0. -1 plus a +2 is a +1. +2 plus a -2 is a 0. -2 plus a -1 is a -3. And then -1 plus a -7 is a -8. So now looking at this situation, we would say, okay, well, what I want to do next is get a 1 right here. So one way to do it is to take everything in the second equation times the reciprocal of 3, or 1/3. But you could see that that's going to kind of give you fractions here with your -1 and your 8, which are not multiples of 3. So maybe the easier way to go about this is maybe we could switch our row 2 and our row 4, which is what I'm inclined to do here. So we're going to take row 2 and row 4. I'm just going to write this on the side. Row 2, swap it out with row 4. Let's look at what we have. So row 4 would basically be what row 2 was, is 0, 3, -1, 3, and this 8 here. And row 2 would be now this 0, 1, 0, -3, -8, and row 1 would be the same. 1, -1, 2, -2, and -1. And then our row 3 still would have been the same. So 0, 0, -3, 3, -3. So now using this 1, we want to get zeros underneath it. The nice thing is that we don't have to do anything here because it's already a 0, but we have to use this 1 to get rid of this 3. So what we're going to do is we're going to take that 1 times a -3 and add it on to that last 3 there. So to write this out as a row operation, we would say really what we're doing is taking row 2 times a -3. So we would say -3 times row 2. We're going to add that on to row 4 here to get rid of that. So row 1 still the same. 1, -1, 2, -2, -1. Row 2 still the same. 0, 1, 0, -3, -8. Row 3 still the same. 0, 0, -3, +3, -3. And then the last row would be now a 0 and definitely a 0 here. But let's think about this. -3 times our second row here. This would be -3 times 0 is 0 plus a -1 is -1. -3 times this entry here would be a -3 times a -3, which is a 9. And 9 plus this 3 here would have been a 12. And then we would say, now let's take -3 times our -8 here, which is a +24. And 24 plus this +8 here would give us a +32. And so moving forward from here, it looks like we have a 1 here, zeros underneath, 1 here, zeros underneath. Now let's get a 1 here. And it looks like we could take easily this entire row times a -1/3. So what I'm going to do is I'm going to stretch this back up over here. It's kind of a common thing that I do here when I have this much work. We'll do it in columns like this, but we're going to take the entire third row times -1/3. So -1/3 times row 3. So row 1 still the same. 1, -1, 2, -2, and then -1. Row 2 is still the same. 0, 1, 0, -3, -8. Row 3, we took a third times everything in row 3, so we have a -1/3 times 0, and 0 would be 0 and 0. We would definitely have a 1 here now. 3 times -1/3 is a -1, and then this -3 times -1/3 is a +1. And then the last row here we didn't do anything to, so we have a 0, 0, -1, 12, and we have a 32. So now that we have a 1 here, let's use this 1 to cancel out the 1 below it. The nice thing is if we were to just say, well, since it's already a +1 and a -1, we don't have to multiply row 3 by anything to add this on to row 4 there to get to cancel. Or we could interpret this as really what we're doing is we're taking row 3, okay, row 3 times 1, which is the opposite of this -1. We're adding it onto row 4. So row 1, 1, -1, 2, -2, bar, -1. Row 2, 0, 1, 0, -3, -8. Row 3 is 0, 0, 1, -1, 1. And then our last row we have 0, 0. Now if we were to add row 3 plus row 4, 1 plus -1 is a 0. -1 plus a +12, okay, would give us a 11. And we would say, I'll put that in purple here, we would say in the last row, if we were to take 1 times 1 and add it to 32, we get 33. So with this last thing here, we could say that if we were to take really our last equation times the reciprocal of 11, we'd have a 1 there also. So we're going to say 1/11 times row 4. And here's what we get. We get 1, -1, 2, -2, -1. Second row, 0, 1, 0, -3, -8. Third row, 0, 0, 1, -1, 1. And our last row becomes 0, 0, 0. 1/11 of 11 is 1, and 1/11 of 33 is 3. So now we could see that the system that we had started with, we had x minus y plus 2z minus 2w. And I just want to check on this here. Actually, our w's came first. So that would mean that we have really 1w minus x plus 2y minus 2z is -1. Our next equation, we would have had x minus 3z's is equal to -8. Our next equation, we would have had y minus z equals 1. And our last equation, we'd have z equals 3. So the cool thing about rewriting your system is that we already know one part of our ordered quadruple here. We know the last part, z. And we would say that we need to find the other parts here, w, x, y, and z in our ordered quadruple. But basically, now that we know z is 3, let's plug that back in here. We can say, well, then if y minus z is equal to 1, then y minus really 3 is equal to 1, and therefore y must be a 4. So now we know y is a 4 here. We'll fill in 4. We'll put a box around it. Also, because z is 3, in the second equation, you could see that if we were to just plug in, say, z is 3 here, that's our z, x minus 3 times z is equal to negative 8 from our second equation here. We could say that really x minus 9 is equal to a negative 8 here. So adding 9, we get x is equal to a 1. So now we have this, and then our last thing that we'll find here, 1 here for our x. The last thing we need to find is w. Well, we know that w minus x plus 2y minus 2z is equal to negative 1. And so if w minus x plus 2y minus 2z is equal to negative 1, let's substitute in what we know. We know x is 1, we know that y is 4, and we know that z is equal to 3. So really what we get is y minus 1 plus 8, okay, minus 6 is equal to negative 1. When we combine our like terms here, it looks like a negative 1 plus a positive 8 is 7. 7 minus 6 is 1. So we get w plus 1 is equal to negative 1. So w here must be equal to negative 2. And so you can see that this process works with just as well with 4x4s as it does with 3x3. So what I'd like for you to try here is go ahead and try to carry out this process with this 4x4 system here and see what solution you come up with. Cheers.